Hello everyone. In my previous recordings, I talked about tools, talk about assistant bots, and the reason I've done that is that I really had to introduce a lot of different concepts. So I'm not going to repeat any of these today. And the second reason why I was talking about that was that for majority of people, the way they've got introduced to all concepts about agents was through ChatGPT-like interfaces. Because this is basically where the first time most of people got introduced to all these concepts, and without even knowing, they kind of gently move from basically question and answer sort of application to more like kind of a chatting applications whereby the ChatGPT-like interfaces can start picking up information, not only what is stored in their databases, if you like, of tokens, but as well start calling some additional tools or endpoints before giving you back the answer. Now, looking back at what we discussed was that we had some sort of assistant layer around the LLMs that was picking up different tools that expose their own capabilities. And then eventually we had something like a context video sessions, if you like, that were managing the conversation, if you like, before giving you back the answer. Now, in the last couple of weeks, if you like, we start hearing more about MCP servers. So I will be introducing that as well because it has to do something with tools, by the way. And then we'll be talking about as well as not only this sort of multi-agent applications, that is very much like assistant bot applications, but also something that often people think when they first time hear about multi-agent applications, which is intuitively something like I have a lot of different personas that can solve one problem at a time, and somehow you have to manage their collaboration before you come back to a result, but not necessarily through conversation. Now, before we get there, and I will actually this time also have some code to talk about, let's go back to the MCP server and what is that stuff about? Because it is a kind of recycling of the old idea of API proxies, or if you like, API marketplaces. In the past, we had the idea of API to API marketplaces where you would actually go to a marketplace and that would be kind of a broker to different API endpoints. And you would not need to worry about these keys. They would also provide you with unified billing. So you have like maybe a key towards that API proxy, and they would be managing for you connection to other endpoints. MCP server, in a way, it's a very similar idea whereby you're not exposing directly API endpoints, but you're exposing them through the servers which are talking to these endpoints. Now, in our environment as well, when we look at the studio and we look at the tools, it's pretty much the same thing. Our plugins are also sort of wrapping the APIs and providing capabilities. So over time, we have extended that, and now we also made it MCP compliant. But we actually needed to have pretty much the same thing as what is now de facto becoming a standard. What does it mean in practice? It's that, for instance, if I'm going to take, I always use the same example, by the way, I hope you don't mind that. If I am looking at information about the weather in London at this moment in time, notice here I have to manage my own keys. I'm going to get back the answer. Now, when we talk about capabilities, sorry, in the tool sense, they care only about inputs. Obviously, they're going to provide something out, but this is not often what they provide in specification as what is the capability, which is kind of strange. And it's strange also if you want to use them in a classical API orchestration sense, you really have to know how to, if you like, stitch the outputs to inputs to other systems. That is to say that if I'm gonna use in a classical orchestration sense, information about the weather, and I would like to say if it's freezing or not, I really need to know that the previous guy here can give me information about the temperature. This is how we used to and still use the API endpoints. And notice here that in our studio, you do not have to care or think about these things. The API endpoints can be perceived as the tools for assistant bots, but can be still used in a good old way as a simple API endpoints, which you kind of stitch together and make more deterministic reasoning, if you like. Now, coming back to servers, MCP servers to be precise, what we start seeing is that many companies that in the past were delivering APIs through Swaggers and other things start exposing their capabilities as the MCP servers. That is to say that I can have another organization. It doesn't necessarily have to be even a Twilio, for instance, or SAP here. You either connect to SAP SaaS and they will start delivering MCP servers, or someone else can actually wrap it for you. And in a way, you can actually even think about it as a tunneling. And then, as a matter of fact, that our API Jetting Studio can connect to multiple SAP servers as a client. Again, in our studio, we are connecting it. We are adding some, if you like, non-standardized things inside because we needed that in our application. Now, let's now look at that first. And like I said, I will be showing a little bit of code. And please bear with me that this is not what I'm showing here, a really MCP server compliant server, but because it was not point of this video. Point of this video is with a limited set of codes, you kind of get a feeling of what this thing does and what it's supposed to do. Notice that the current implementation of MCP servers not only serves as a proxy, it also provides a way for agents to communicate. That's often happening through the WebSockets. You will also often hear something about SS events because this is the way for a server to talk to the client over the HTTP. So in a way, you can actually think of it now as a sort of the asynchronous way to distribute information and capabilities. Now, this is what I'm gonna also, if you like, open source. That's not a big deal. Its idea is to have really few lines of code that get you feeling what you can do with this thing. So if you like, my non-standard compliance server has the capability for the agent tool communication over the WebSockets. It has the HTTP endpoint to register new clients. And it has a little bit of a Redis in case that you want to extend it with some other system to delegate message passing, because now everything is happening inside the server itself. So let's look at a little bit into the code. It has only hundreds of lines of code, less than 200. It's written in Node.js because it's kind of easy and not so many lines of code you have to write, basically. This is my HTTP server. This is my WebSocket server that it's tied, if you like, to the HTTP, if you like, here. That's what's happening here. And then I have two maps. One of them is to map agents and the sockets through which they connect. And I have another map that I'm not using right now that can be any additional client that wants to tap into the MCP server to make use of that. This is where you typically add your own agentic applications. So you can see agents will be kind of a data distributor, and then you will actually use this information in your multi-agent application. Not going to talk much about that. For people who are into the code, will pretty much understand what's going on here. For every socket that connects, it's going to have a socket ID, so I keep that in the map. I will have a message that will be published into the Redis for a PubSub. On disconnect, I'm just going to disconnect this WebSocket. And then when we subscribe to it, we can actually look at the target socket and emit the message, like a message broker passer. That's not that it's important because these are the SSEs. I'm not going to use them. And there is here important part, which is a discovery. How many agents or tools I have. Notice I'm sometimes mixing agents and tools because, to be honest, you can also expose agents as the tools. You can also expose assistant bots as the tools. And then they will be emitting the answers on your questions. So it can really go really quickly in all kind of directions. This is to broadcast the SSEs, but anyway, so this is pretty much what the MCP server does, and I'm gonna start it here. So this is now my MCP server-like application, and now I need to write a first client. The first client will be something that can mimic data collection. Now, what I'm doing here is that I need a capability that says, okay, so what I need an asset for which I'm going to retrieve information. Notice I'm adding in capability what it can produce. So far, as far as I know, this is not in standard yet. Like, okay, this is what I can emit as a capability. The reason we are doing that is because in the classical flows, we definitely want to know this information. Again, coming back to our Agetic Studio, we can use tools either as ingredients to the flows or inside the Agetic applications. Here I'm simply connecting to it, and here I can emit my capability, which is that, okay, I want to get a matrix, fine, give me the asset name, and then I will just simply emit that back in response here, and that's it. So whoever is asking for that, I need a name, and then I will give you that random values. This is just a registration code. Given the adjective name, I can emit my capability. So let me start this one here. I believe this is one here. So what you're going to see now is that I'm emitting the capability. So I have registered one client, and that's it. My next client will be, again, a weather agent. Now, this time I will really go to the Open Weather API endpoint. It's very similar, so I need to know the city. This is what I'm going to return only the temperature. I've added a little bit of a caching because API endpoints often get asked to do the same thing, maybe sometimes even in milliseconds. Sometimes you just do not want to hit that API endpoint too quickly. And I am basically here having a cache of 5 minutes. That's probably good enough even in Belgium. So meaning that I will be caching the response, and if the response is not in the cache, I will call again the weather API and send this response back in here. This is the data I can send back. Let me start this agent as well. This is going to be my weather agent. So notice now I have two agents configured. One is going to be the metric agents, which is going to mock up the data. And the second one will be the weather agent. That's pretty much what the MCP serverless is about. You're going to extend it with your own capabilities, your API endpoints, but you're not going to be exposing them raw, if you like, but through better means to use them in your agentic applications. Finally, the last agent that I'm going to start, it's if like our own agent that expose our own API endpoints as the tool. And here this time, I'm going to run one specific rule for the diagnostic test. That means that I'm adding the capability to run the diagnostic tests, and this is going to be actually this flow here. So I'm going to have a flow that can do, based on the inputs, check for the temperature, airflow, and energy. And if these things are above a threshold, it's going to fire alarm that we need to change the filter. So I decided that my client needs to know what is the weather outside. I'm going to get the temperature, airflow, and energy use. And if it's too hot, maybe energy is just higher because I'm in a rather warm environment. Okay, now that I have this agent, that is this one here, I'm going to start it here as well. So let me start the whale agent. And this one can run a template. And I need, like I said, I need the name of the template. And I also need actually the variables. In this case, that will be for the HVAC diagnostic test. Now, finally, I can really run the multi-agent client. And this is going to be the guy here. And I would just really like now to pause here for a second and see what's actually happening here. I'm gonna emit two messages, one towards the weather agent, and I need to say this is my request and this is the entry. I'm interested in, let's say, Berlin. And I'm also interested in the data of the HVAC file. Now, here it's now the fun part. And now I have to go back here and describe this part here again. If you do not care about the order and only that data arrives in pretty much the same time, the agent 3 will then use information of the other two and then execute something. So it's kind of like a split and merge pattern. If you need an ordered sort of things, you can think of it as a pipeline. But then the point is like, what's the point? You can as well then make it as a flow. But again, the point I want to make here is that I would really like to introduce the concept of MCPs and as well how we can use them in the, if like, agentic application. If you look at here, I'm not going to do anything. I'm just going to basically say, okay, I've got both of these things and that's it. Now, if you look at the videos of the long chain, this is where these guys are entering. So they're injecting now the flows in here that can describe, am I expecting some of the inputs first, and then I branch to other things, am I gonna loop, ask for additional information, and so forth and so forth. Right now what I'm doing here is that I'm just waiting for these things to happen. And they have to be arriving within the timeout, which I believe is something like 5 seconds. Now let me save this and just run this client here. What's gonna happen is that you see that I actually have hit this one to get the weather from Berlin. And notice now here, probably I have just gonna cache this stuff now. Okay, there we go. I just hit it now and it's gonna be there for 5 minutes. So that was the memory of this guy. I've emitted this thing as well. The server received all of this and then send it back to me. That's what I'm seeing here. Okay. The next thing I'm going to do is that I'm going to stop this guy and go here. It's really not a great multi-agent application, but in a sense, it does something already. I'm going to say here, I have received both of these things. That's what's happening here. And I'm going to emit a message to the next one to use this now and do job for me, which is to say I'm going to run now diagnostic test because I have received both values, even though now I just needed one to run the diagnostic test, which is the data from the HVAC. And I can afterwards extend that. Now, let me do it again and see what happens. So I'm starting the client again. This one sent me back data from the cache. I got the new value. And now the third guy got invoked because once I receive this, I have decided actually have to call the next agent, which was this guy here. Now, if you look back into the studio, what has happened is that we have actually hit this thing here. So that was the flow that was exposed as the tool inside the MCP server as a capability and invoked the diagnostic test. Now, the fun part is that this time, these endpoints are not exposed to tools, but again, as a flow here. And which meant that in a deterministic way, I decided what to do with that information. Like I said, sometimes these multi-agent applications can do a lot of different reasonings, and sometimes you want some of these sub-rules to be very deterministic. So I'm not trusting here any LLM, if you like, reasoning engine, to do decision based on the data itself, whether need to replace a filter or not. I'm going to actually create it as, if you like, as a subflow, but still use it inside the multi-agent application, meaning that this is my, if you like, the diagnostic test as a session. This was the log of that, and eventually we figure out there is no problem with the filter. That is pretty much what I wanted to talk about today. So what I want to have you to take from here. You will find yourself sometimes plugging to different MCP servers as a client. Like for instance, our studio can connect to our MCP server or the others. Sometimes you want in your own enterprise to expose APIs as the tools. Sometimes you will be talking to other MCP servers. That's why we need the standardization. That's why Claude is pushing for that, such that other companies can expose their capabilities to be using in the multi-agent applications. Another thing I just wanted to say is that in many cases, what you're going to be then building, it's some sort of assistant bots, which is what we can do here as well. These are the assistant bots. And for instance, here, I'm actually doing a diagnostic test. I'm not going to complicate story too much, where I was delegating to the assistant API to figure out what it needs before it was calling my diagnostic test. In this sort of application, I was actually doing in here. So I have not delegated to reasoning engine, okay, giving this and that. Oh, you want me to run a test? Oh, before it, I need to call another endpoint to retrieve the data information. To conclude, even the assistant applications are written in exactly the same way. So if we hear someone saying that LLM is adding the reasoning and start doing back and forward, this is the place where these guys go. So they're basically then emitting themselves what they are requiring in order to proceed. And in order to proceed, it's what is happening here. And again, you can actually then plug LangChain-like workflows, or you can plug our reasonings, and then this is where the fun starts. In the next video, I'm going to talk about something which is even more fun, and that is about call-seeking agents. Now, that also means that at that moment in time, optimization in the score will be delegating to a lot of agents of the same kind or not. And this is going to be a pretty fun thing to do. And again, I will try to make a very simple examples with few lines of code, as little as possible, just that you guys can grasp the idea about what's going on in this space, which is moving really, really fast. Thank you very much for watching. Bye-bye.